This video is sponsored by Squarespace. In normal photography, many of us rely on autofocus. The camera and lens work together to automatically focus the subject when you press the shutter down halfway. And this works because any lens with autofocus is going to have focus motors built into the lens body here. And then those motors are designed to be controlled electronically through these contacts right here on the lens flange that connect to the camera body. On the other hand, almost all telescopes off the shelf are manual focus only. So we need to actually turn these manual focus knobs in order to focus on the stars. However, we can add autofocus to almost any telescope with something like this that goes for about $200. This is an electronic autofocuser designed for telescopes. Hi, my name's Nico, and I do astrophotography full-time thanks to the community support on my Patreon. And this video was actually suggested by one of my Patreon members named Jan, and he'd been struggling a little bit to get his ZWO EAF working. I was able to help him with it, and he said that I should make a video about the topic. So here we are, and this is going to be a basic nuts and bolts kind of video showing you step-by-step the installation and the configuration process for a telescope autofocuser. And I will be using the ZWO EAF for this tutorial because it's the most common brand that I typically see people going for the autofocuser, but I will be going through basics that I think would apply to other autofocusers if you happen to use a different brand. Okay, so let's go ahead and get started. This is your typical telescope focuser. So on this side, you have the coarse focusing knob. This is also a coarse focusing knob, and then this is the fine focusing knob, which is a 10-to-1 reduction. Okay, and then here, this little screw in the bottom usually comes in a little baggie, and you install it. It's the locking screw. Once we actually install the autofocuser, we're going to remove this locking screw, and the telescope focus will be locked. We can't manually focus anymore once we put the autofocuser on there, at least with the ZWO EAF. It locks it in that position, and then the only way to move this focuser is through the autofocus motor, which you're going to have to control either with the little hand controller or with software. The first step, though, is we need to install the electronic focuser, the EAF. And where are we going to install it? We're going to put it on this side. So we're going to replace this coarse focusing knob with the motor. Okay, so the first step in doing that is to actually take off the coarse focusing knob. What I would suggest is go ahead and lock down your focus like this with that little hole right there straight up, so that this isn't going to move around as you're trying to undo that set screw. Okay, and then your autofocuser probably came with 2 Allen keys. For this set screw, it's almost certainly going to be the smaller of the 2 Allen keys, so I'm just going to open this bag and put that in there, and then loosen the set screw just by turning the Allen key in a leftward or counterclockwise motion until it's loose. And then once it's loose, this whole knob just comes off quite easily. Now, what I would suggest is to put this little coarse focusing knob with the set screw in there in like a Ziploc bag and label it and say, this belongs to the ASCAR 71F telescope, and keep it with your random telescope parts. But definitely label it so you remember, where does this actually belong? What telescope? Okay, with that coarse focusing knob removed, we can now see the focuser shaft inside there. And if I loosen this locking screw and turn this, you can see that focusing shaft moves as I move the focuser. What you want to look for is that one side of this focusing shaft will have a flat surface. And it's just important that when we attach the next part, which is a coupler, which is what's going to attach the EAF to the focuser, is this coupler. The important thing is that at least one of these set screws here is making contact with the flat part of the focuser shaft. Now there will be a couple set screws on each side, so you can tighten them both down So one of the set screws is going to be making contact with the round part of the shaft, just as sort of like a safety, to strengthen up the connection a little bit more. But you just want to make sure that at least one of these set screws is directly on top of the flat part of the shaft on both here. And then we're also going to make sure that that happens with this one too, which also has a flat part. Now, depending on your focuser model, how old it is, or which brand, you might have a coupler that looks like this, which is flexible in here, or you might have one that looks like this, which is rigid. Usually when you buy a focuser, it's going to come with many different couplers. And the reason for this is on one side of the coupler, it's always going to be the part that fits onto the ZWO EAF, but the other side, there's many different size holes there, so because these shafts on the different telescope focusers come in different diameters. So that's why you have all these different couplers. So the next step is just finding the coupler that is a good fit onto that shaft. So there should be one in the bag that is like basically a perfect fit, not too loose or too tight. Go ahead and put it on there. Now, a mistake I often see people making is putting it all the way in to just jamming it all the way in. But if you look carefully on most focuser shafts, this little flat part doesn't actually extend all the way in, and it actually goes back to a rounded shaft there. And so if we go all the way in, it's going to be at sort of a weird angle. So you actually need to leave a little gap here between this part of the focuser and where you attach the coupler. Okay, and then we're just going to use the same Allen wrench that we used before to attach that, like so. And then you can loosen your focuser if it's not already loose and go to the other set screw and tighten up that one. At each step of this process as we're adding things, what I'd recommend is to make sure that things are working as you'd expect them to work. One thing that you can do right now is just take the whole coupler and see if you can move the focuser back and forth just by hand. Because, for instance, if this was loose, then this would no longer work. You'd no longer be able to move the focuser like this. But this is all working well, so we know that we did it correctly. Okay, so we have the coupler on there securely. The next thing is we need to attach the EAF. That shaft is going to go into there, but we also need to attach this bracket to firm up the connection of the EAF to the telescope. So I think the best order for this is we're gonna attach the bracket loosely. We're then gonna slide in the autofocus motor and attach the motor to the bracket, then tighten everything up. However, there's one thing that I would suggest to do before we actually even attach the bracket, because it's gonna start getting in the way, which is, so we're lining that up like this with this, and then I'm just gonna turn the coupler until this set screw right here is lined up with the flat part of this shaft. So see here, it's not lined up because my shaft, the flat part's right there. So I'm going to turn this until those are lined up. So then when I tighten this all back down after I've attached the bracket, it's all ready to go. If you forget this step or this seems too complicated, another thing you can do is get power to your EAF through the USB. If you have the hand controller, you can attach that, and then you can just move the shaft to whatever angle. So if I powered this up right now and attached the hand controller, I could just move this shaft so that the flat part was straight up. Sometimes I like doing it that way. It's really up to you though, but this way you don't even have to power up the autofocuser. You can just move this so that everything is at the right angles. So the flat part is facing me now, and this is lined up like this. Okay, next step, go ahead and take out the locking screw. Okay, and there'll be a bag of screws that came with your electronic autofocuser. Find one that works with that same screw hole. This focuser actually has 5 screw holes up here, so we're probably going to want to attach the bracket in a couple different places. Okay, and then there will probably be a washer in the packet and the screw, and you put the screw through the washer. If you don't want to keep track of this locking screw, another thing that I see a lot of people do is just actually use the locking screw as one of the screws to hold on this bracket. I think that's a good idea. So I'm just going to use that as my second screw down here. And there's no need to tighten these up much yet. We actually want to keep this loose at this point so that we can adjust the spacing over here with the electronic autofocuser. Okay, so now at this point, I'm going to bring this into the coupler right here, the shaft into the coupler. We've already lined up that set screw on the side here. So then I can just get the spacing just right. And again, you don't want to push that coupler all the way up to the edge of the focuser body. You need to leave a little space in there. Okay, I just changed the angle here so you can see this because this is an important part. There's probably going to be about a gap here between the EAF and the coupler that's about the thickness of this small Allen key. And that is so that this set screw right here makes good contact with the flat part and it's not rubbing up against the autofocuser body at all. Okay, so just keep that in mind when you're adjusting the distance of this to the coupler. About that much is about right. It could be a little bit more, a little bit less, but like that, you don't want to push this all the way up against the coupler. Okay, I'm going to switch this back to the angle we were at before. Okay, so remember this part is held on by these two things here, but it's still loose. So the reason for that is we can now push it right up against here. And then there should be in the bag 2 little M4 screws. And on the focuser body, there's 2 screw holes right here that we're going to attach these two. Okay, so you see there's 2 screws right there. You're going to use the bigger Allen key to tighten those. Okay, and then the order that I would tighten now is go ahead and tighten this down. Okay, so now the bracket is tightly attached to the EAF. Then I'm going to turn it back up this way so you can see. Then you're going to tighten these 2 screws. So in my case, this one is this M4, the bigger Allen key, and then this one is a thumb screw that came with the telescope. Okay, and now this bracket is very securely on there, so the EAF is very rigidly attached to the focuser assembly. And what you can try now is try just moving, don't do this with any force, but just try a little bit, just try moving this coarse knob on this side, and you should feel that it's locked. What you'll see is that if you go like this, you'll see the fine focuser knob moves like a little bit, just like a little wiggle, but don't force it. Just let it be like this, and it's locked, okay? If you have access to all the different set screws, go ahead and go in there and just give each one a check. Okay, while you do want all these set screws to be tight, I will warn you they're easy to strip, and you really want to avoid that because if you strip the set screw, then you can get into a situation where this coupler is like permanently attached to the focuser shaft, and you don't want that. So the key thing to not strip them is just make sure that when you put this hex wrench, this Allen key, into the set screw, that it's actually fully in there and you're not just sort of like trying to jam it in at a weird angle. So just take your time and just make sure that you actually find the angle for the Allen key where it's going into the set screw and is not just sort of like jammed in at some weird angle. that it's actually in there. And it can help to actually look at it and then look at the angle of the Allen key and just line the two up. So once you have this all installed, now is the moment of truth, which is we're going to test it. You can do this inside, doesn't matter, and just make sure that it smoothly moves the focuser back and forth. And there's a couple different ways you could do this. One is you can attach the focuser to a PC or to this guy, to an ASI Air, just with the USB cable. I have an older one, so it's still this USB-B style. Once you connect it to the computer ASI Air, you can just then open up the software and move it using the software controls. An even easier way to go about it is to buy this additional device, this EAF controller, hand controller. You just plug that in as well as the USB, because the USB is needed for power. And you can put it on fast and then just try. So I'm going to move it one way. This is moving it, you can see, in. And then move it the other way. And you can see the focuser is moving out. Now, I should have said this at the beginning, but if you know where your camera comes to focus and your focuser travel has these millimeter markings, you can now go ahead and just move out or in your focuser to the point where you know it roughly comes into focus. Because for the autofocus routine to work, you have to start roughly in focus. So if you don't know this, if you're installing this and you either forgot how far this should come out to reach focus, or this is brand new to you, this telescope, just get out under the stars. And if you have this, just loop exposures, or just take a test exposure, move in, take another test exposure, move in, and eventually you should start seeing some big out of focus stars appear, and then you can fine tune it. And when you get really close to being in focus, you can go down to the slow mode and it'll just move the focuser in much slower increments. And of course, when you also get close to focus, you can use a Batonov mask if you have one to really make sure you're in focus. So again, steps are, after you've installed it, go ahead and either with the app or with the hand controller, make sure that it's smoothly moving in both directions. Now, what if it's not smoothly moving in both directions? If you find that you can move it one way, when you try to go the other way, it just doesn't move. It just sort of like locks up. That is almost always some issue with your physical connections here. So if this is, askew, if anything is loose, you just want to make sure that everything is just like solidly put together here. Basically, if you find that it's not working, it's time just to take this all apart and start again. Just try to slow down, make sure that that you're attaching to all flat surfaces, that along every step of the process, you're making sure like, oh yeah, the coupler is tight onto the shaft there. This is all square, all these different steps so it's mechanically solid. And then if you've done all of that, it should just work like this. It should be able to move the focuser in both directions, and that's all it needs to do to work as an autofocuser. Okay, but now that I can see this is all working, we're ready to bring this out under the stars. Okay, we're in the ASI Air here, and I have my camera connected, and the EAF is also connected. If you don't have your EAF connected, just go up here to EAF, and you should be able to connect it right here. If you have it plugged in over USB, it's this symbol. If you want to connect it over Bluetooth, it's that one. I'm going to connect over USB. And so this is one sort of autofocus screen. This is the focus settings, basically. But this current position and go to is actually a control option. So there's a control option in the settings, just so you know. But the main control thing is actually over here on the left. It's this little focuser thing right here. And if you have it on slow mode, when you press one of these up or down buttons, it's going to move in the number of steps that you have for the fine number of steps. So that was 10 by default. And in the fast mode, it's going to move the number of steps for the coarse setting. So I think that was 100 by default. Okay, if you want to increase or decrease those numbers of steps, you can just go back here into the EAF settings and type something else in. So for instance, if I take a picture here, and I can see I'm pretty far out of focus because, like, you know, this autofocus star is still pretty big. So I know that I'm going to have to probably move a bunch of steps, but let's just see. If I just move 100 steps, how much that autofocus star changes. Barely at all. So yeah, I was right. So I think that I'm far enough out of focus that I'm going to want to set my course setting higher. I'm going to set it to 500 steps. Okay, and then I'm going to try hitting that once and taking a picture. And I hit the down arrow in this case. So if the autofocus star gets bigger, which it did, then we know we have to go in the opposite direction. So now I'm going to hit the up arrow twice, and the autofocus star should get much smaller. Yes, so it is. Now, I'll mention that this way of doing it, of controlling it with the arrows, is of course only one of several control options. So another is if you have the hand controller, you can just use the buttons on here. And the nice thing with these buttons is you can actually just hold them down. So I'm going to hold down the up button, which is pushing the focuser out. And you can see now we're getting a lot closer to focus. So I'll just go a little bit more. So now that looks pretty close to rough focus. I'm going to switch to a Badenov mask just to make sure. Okay, I can see I'm a little bit out of focus. So this is where it can be handy to switch to the slow mode. So I'm going to switch to the slow mode. Okay, that looks pretty good. I'm going to take another test exposure. Okay, and then I'm going to press the detect button over here on the left. This is going to calculate the star size. Okay, and I can see the star size is 2.3. We've now reached a point where we're basically in focus. It could probably be a little bit better. But if we look at the focuser position, we can see it's 29,281. That sounds good. If our limit is 60,000, that gives us a huge amount of range to work with. Like, you want to be sort of in the middle of the range. Now, let's say you went through this whole process and for some reason it said current position right here, 20. I don't know, something very, very low. That's not going to work. So you would then want to actually change the current position. You can just type something in here. So I just changed it to 30,000. But it was fine before too, at like whatever it was, 28,000, whatever. The point is just you don't want to be too close to either end. When you're at the good point of reaching focus with your telescope, you want it sort of right in the middle of the range. So if it's something strange there, you can change it. Otherwise, you can just leave it alone. I'll also mention this right here, this go-to function. So this is another way just to make big changes in focus position. So I already mentioned this coarse and fine adjustment, which you can do with the slow and fast buttons over there. But if you ever just want to make like bigger changes because you're finding focus and you're finding using those buttons is too slow, you could always just type something in. Here in the autofocus settings, 2 seconds is probably fine for, no filter. But if you're going to be using like a heavy filter, like a dual narrowband filter, I would probably increase that to maybe 5 seconds, maybe even higher depending on
the bandpass of the filter, but 2 seconds is good for no filter. And I think the default step size is 30. I find that that's maybe, with a lot of telescopes, probably a little bit conservative, and it's going to make it so that there's lots of steps. So I usually increase that a little bit, like to 40 or 50. Let's try 50. Okay, and now we're ready to try an autofocus run. So we'll just click on this little AF button down here. So if you don't see that, just tap on Focuser and then tap on AF and then hit play. Okay, and it just moved the focuser out quite a bit, and now it's finding a suitable star that it's going to track as it moves the focuser. And once it finds that star and takes a picture of it, it'll appear in this upper left box here. And when it first appears, it should be very bloated and very out of focus, like that. And then this green line that just appeared is it trying to basically fit a curve to those samples. So basically each time it takes a picture of that star, it's a sample, and then it's basically now mapping how the star size is getting smaller with the change in focuser position. And eventually the curve should start going back up in the other direction. Yep, see, it just did. See, that sample is now higher. And this curve actually looks pretty good without any backlash compensation. Let's see here. So that's basically it. Now there's more to troubleshooting, of course.
Okay, I'm going to draw out some focuser curves and sort of diagnose what's going on if you see these different problems with your autofocus curve. So let's start by just drawing out an ideal autofocus curve. This is what you want to see. If you see this, you know that all your settings are fine. You don't have to do anything. So an ideal autofocus curve, you're starting roughly in focus. So the in focus position is going to be right in the middle of here with the focus position. It's going to move the focuser out and start out here and start making points down like this, and then come up on the other side like this. And so the curve should look something like this. So it's just a nice, even, hyperbolic curve like that, where it comes down, it sort of makes like a U shape down here at the bottom, and it's pretty even on both sides. Now, if you start out of position, like if you're not quite in focus, like let's say you started here, but then the actual focus position is over here, that still should work. So, but in that case, your curve wouldn't look so even. It would look more like that or something. But as long as it's able to sort of make a nice sort of gentle U like that and come up at around the same slope on the other side, you're still good. You still don't have to change any settings. So either of these two, we're going to say, are ideal. Don't have to change anything. Okay. Now, if you start your autofocus run, you hit the play button and you basically get this. So it's not making a curve. It's just making basically sort of a line. Maybe the line has a little bit of variation. There's one of 2 or 3 things that be going on here. The first thing to check is try increasing your step size. So it could be that your step size is too low. And so if you see this and it's just not making a curve, try increasing your step size, because maybe it's just not moving the focuser enough to see sort of that nice curve happening. The other common thing that's happening here is there's a mechanical issue with how you set up the focuser. So again, that's why it's really important before you run an autofocus curve, make sure that the focuser is moving smoothly in both directions, because if there's any issue with the focuser not being able to move, then of course you're not going to be able to get a nice curve. So the other diagnosis of this is mechanical problem. And so check that, just the basics again, check that you can move the focuser in and out, and then check your step size. Okay, the next kind of curve, what if this happens? Basically, it makes a step here, it's measuring the star at something like 15, and then the next one it's like at 2. And then all of a sudden it's way over here and it's at 18. That is step size is too high. It can't make enough inferences from just this kind of thing where it's basically jumping too far. So it's way out of focus, and then it's maybe in focus, but maybe there's a better focus here, but it doesn't know, because then the next step is way back over here, way out of focus again. So if you see something like this where it's just jumping around and then it's trying again, but it's still just making this very sort of jagged kind of curve, that's step size too high. Okay, next one. This is going to be a really common one. You'll see that it starts maybe like there's some issue, right? Where like the step size is too low, like it's really not moving very much, like this. And then all of a sudden, it's like it kicks into action and you have a big drop like this. And then maybe you have one more here, and then another big up like this, and then maybe another one, and then it starts doing this again. So basically you get this kind of thing where it looks like a bat, right? See, like the bat wings like this. This is an issue with backlash. So it moves the focuser out here, way out of focus, but then when it reverses direction, there's a lot of slop in the gears. And so it's taking quite a while before it can actually engage the focus gears and move the position. And so this is an extreme example of backlash. You might get a much less extreme one. It might be something more like this, where you just have a little bit here at the start, but then it basically makes a normal autofocus curve. And in that case, you really maybe don't actually have to do anything. But if you're sort of being a perfectionist about it, you can add a little bit to the backlash compensation to get rid of that. Maybe just like 10, 15 steps. If it's a case like we saw before, like this, then you're definitely going to want to deal with the backlash compensation. And so the issue here is backlash. I'm not going to get into how to measure backlash. There's other YouTube videos that do that if you're interested. Just something that's almost making a curve, but it's like you have like these like weird ups and downs. My guess is that this is a measurement error where it's not able to measure the stars accurately enough to give you a nice focus curve. And so usually I would say the issue here, especially if you're using like a narrowband filter or something, is that your exposure length is too low. So you need to increase your exposure length so that it's measuring the star well enough to actually make a good focus curve. Okay, last thing is if you have the default, if you're using the ASI Air and the EAF and it's doing its thing very well, but it's just making a lot of points like that. And it just takes a really long time to complete. I think usually what you can do to speed this up is just increase your step size, because if in some you can actually, some focusing systems you can tell it exactly how many steps to take. In ASI Air, it seems like this step size is the only sort of control you have. So I think that just increasing your step size means that it will just sort of get rid of these sort of intermediary points and just get you down into focus faster. So if you find that you have everything working and your problem is just that it's taking too long, then the answer is usually, I think on ASI Air at least, is increase step size. The other thing, I guess, with taking too long is you could decrease your exposure time. So if you have it at 5 seconds and every one of these samples is taking 5 seconds, try setting it at 2 seconds and see if you still are making a nice autofocus curve and coming to focus. And that would also speed up your autofocus run. But again, if you go too low, you might have issues there where it's not actually getting good measurements of the stars, or not finding a suitable star, because all the stars are too dim or something. So play around with that. But basically, this is just sort of some advice where if you're finding, wow, it's really eating up all my imaging time because every focus run takes, several minutes, you could try decreasing your exposure time, increasing your step size, and it should go a little bit faster for you.
Once you have this whole thing working like we have it now it's just up to you to set up these settings right here about when to run the autofocus. So if you're running a mono setup, you can set it to run the autofocus after switching every filter, which is very nice. I would recommend that one. You can also have it set up to run the autofocus at the start of each target after the auto meridian flip. You can have it do an autofocus run every 1, 2, or 5 degrees of temperature change because the autofocuser has a temperature gauge in it. I think for a very fast system, like if you're like F3 or faster, you might want to do this one. Every 1 degree temperature change. For a normal system, like this one's an F7, every 2 degrees is going to be fine.
So it's definitely super satisfying to figure out your autofocuser, get it all working. But what's even more satisfying for me is getting to the final picture and displaying it on my own website, nicocarver.com. And that's where today's sponsor, Squarespace, comes in because they make that super easy. You can purchase your own domain name, like maybe your name, and also hosting all in one place. And Squarespace includes professional templates for your website that are intuitive and easy to customize due to Squarespace Blueprint, which is their design system. Everything you need is included, from a spam-free contact form to selling tools. And so, if you do want to sell, a service, maybe a consultation or a product like prints of your astrophotography through your website, customers can pay however is convenient for them, whether it's credit card, PayPal, Afterpay. So if you need a professional website, check out squarespace.com/Nebula Photos for your free trial. And if you like it, you can get 10% off your first purchase of hosting or a domain with code Nebula Photos at checkout. And since this video is over 20 minutes long, you're now seeing the names of everyone who supports this channel on patreon.com/Nebula Photos. Patreon members get a bunch of exclusive benefits like monthly bonus videos, one-on-one messaging support with me, tons of additional channels on my Discord server, including the monthly imaging challenge, a Zoom call with the whole Patreon community the first Sunday of every month. And that list was just the benefits that everyone gets starting at $1 a month. There are, of course, additional benefits at higher tiers. So I think it's going to be well worth your time checking out what I'm doing over on Patreon if you like this YouTube channel. That's it for this one. This has been Nico Carver. Clear skies.